What is it?
Did you use, was it the resources on data camp, as in the videos, the courses that you were
Yeah,
able to
the
get?
data cam and yeah, and personal research as well. Data cam and personal research. Yeah.
Yeah, of course, personal research must come in because data
Yes.
camp courses is just not exhaustive. They won't give you everything, but at least they'll give you the basics and give you the right direction on what to follow. And if you
Yes.
want to level up or increase your knowledge, you have to go for personal, I think, yeah, personal
Yeah.
studies and more research.
Yes. And
Okay,
I also use the same method. I used to import through Python Jupyter Notebook to load it to ProsperDB. So I use the same method because I use Power BI. To use it in
okay,
my Fabric, I created the data lake and lakehouse as data warehouse and use the notebook to use Spark Python, then use the same Python, then update it and import data from hotspot and load it to lakehouse. Then set up a incremental refresh because there's a data pipeline in Microsoft Fabric. So set up the
I have
pipeline,
fabric
schedule it,
before. Know what the
yeah,
setup is.
then connect it to Power BI. So it's something that I have in mind to achieve this year, and it's actually I'm very proud of that. I've been able to achieve it. That okay now I can do end to end from data engineering to analytics. You know.
Ah, okay, that's fine. So, if I ask you to take us to next week's class, I hope that won't be too much for you.
Ah, I'm still learning. I'm still learning. I'm still
Everybody,
learning. I'm still learning.
we're all learning, no, seriously.
I am still learning.
Okay, oh, no, all right, well done.
Thank you. Yes.
Yeah. So, let me see. I wanted us to do something first before heading into talking about Airflow. But I don't know. I think we'll have to keep that because based on what we did last week, first off, is anyone logged joining us with his PC? Let me see whether I'll send this PowerPoint file to our group. Is anyone logged in with his PC? Nobody. Oh, that's my system now. Okay, marvelous. Uh-huh. Yeah, your PC, right? Let me send.
Yeah,
Good evening.
good evening.
So are you logged in with your PC?
Yes, I'm with my PC. I'm with.
Okay, that's fine. Aha. Let me send this just the presentation, the slides to you today. Then after that, I think I want to minimize using mine. Then we'll just change and I'll use mine for the Airflow stuff. Where is it? So I'll send the PowerPoint to our group right now. And what did I say? Please just mm, mm. Please know what I'm doing. Okay, I've sent it. Please, just help us with that, please. I think that's And let me see how I can join with this my system. All right. So while we're waiting for Marvelous for that, like I was saying, last week's session, I think we did we discussed the project that we did last week. That was our discussion, and then just brushed on ETL and ELT. But the main discussion of last week was actually our project. So someone still asked how the I think it was the one for the UNDP API. Someone asked how I was able to get that to get the pagination. To get the pagination, yeah. So he asked how I was able to get to run all the pages from the UNDP API, and I intended just doing a brief demo on what I looked at and how I was able to get the URL for the next pages. But I think we'll have to hold on that for now if we have actually discussed that. Let's just look at Airflow and see what it means. So welcome to today's session. We're just going to look at Airflow and how it is used in data engineering and what it is used for. What we as data engineers use Airflow for and how it's used. So first of all, what is Apache Airflow? Okay, next please. This is just what we discussed. Okay, we done that. Agenda is what we're going to discuss today. Then what we did last week. So what is Apache Airflow? First of Apache Airflow is just go to the next page. Let's start off immediately. Yeah, thank you. So first off, it is open source. Apache Airflow is an open source work orchestration platform used to develop, schedule, and monitor workflow. What does it mean? First of all, open source means it's open for everybody. As long as you're a programmer, you can make your input. You can make your input for adjustments to include anything into the Airflow package. So now, why it's used is because of its ability to enable us to develop and monitor workflow. Workflow is simply an end-to-end data engineering process. Now, if we're talking here, since we're based on data engineering, anything we're referring to actually cut across just data engineering. So when I say workflow, I'm just talking in terms of data engineering. It's an end-to-end process that we use to complete to make a complete task in data engineering. So Airflow helps us to schedule, to monitor, and also to automate all of these things. Now, you do not need, with Airflow, you do not need to wake up, say you're working remote, and you need to, say your employer is in US, and based on time difference, you need to send in a report, or you need to send in a report at, say, 2 a.m. West African time, which is, I think, afternoon over there in US and all that. So now, rather than you waking up at 2 a.m., Airflow enables you just to schedule your DAG to schedule your pipeline, schedule your workflow, and at 2 a.m., if at the end of that workflow, your instruction is to send the mail to, or to send whatever is the result of that workflow to your employer in US. At 2 a.m., the workflow is automated. It runs on its own, and the report is sent to your employer. You do not need to wake up and start clicking on buttons so as to send in the report. Once you put the time that you need the report to be sent at 2 a.m., it sends that report on its own, as long as you schedule it properly based on their American time or Nigerian time. As long as you schedule it properly, at the exact time you schedule it, the workflow executes everything that is in your process and sends the report as is written in your ETL process. Now, some of the features are, one, it has a web UI. Now that's one very interesting and easy thing about Airflow. It comes with a web UI, a web interface that allows you to see the way your program is, the way your tasks are run. It helps you to see how your pipeline runs. You will see the number of the ones that succeeded, the ones that failed, the ones that are running and retrying all over and all over again. So it gives you a web UI that makes the process, say debugging process, very easy, because using a user interface, you can see everything that is happening in your pipeline. Then also it is pure Python. Now what this means is that it is actually written in Python. So after writing your DAGs are always saved as a Python file. So it is written in Python. As long as you understand Python programming, it's very easy to create your DAGs and work on Apache Airflow. Then also easy integration, and that's another beautiful thing about Airflow. Now let's also note that Airflow, I think it was made open source in 2014. I'm not too sure of I think it should be 2014 or thereabout, but I'm not too sure. So what I mean is not quite long. So it's made in such a way that it easily integrates with all of these modern stuff that we're talking of. Now it can easily integrate with AWS, Snowflake, all of these cloud platforms that are part of modern data engineering tools. So it easily integrates with all of them. All you just need is to download what you just need to do is download the needed library for whatever platform. If it's AWS, yeah, you download the plugins, I think, for AWS, and you can easily work with Airflow. So it has an easy integration, and also it is open source. Like I said before, open source means it is open, and if you have anything that you want to add to the program, you can easily add. If you see that there is a part that does not really suit you, or there is a part of the program that does not really answer your problem as it is, that doesn't properly handle your use case of Airflow at that moment, you as a person, you as a programmer can rewrite that code, send a pull request on GitHub, and your contribution will be added into Apache Airflow, and every other person, of course, worldwide, downloading and using Airflow can make use of your contribution. So that's for open source. The next, as data engineers, why do we need work? Why do we need Airflow, and why do we need to understand it? First off, it automates ETL and ELT pipelines. That one is self-explanatory. It just automates the running of your pipeline at a specific time, a specific schedule, whatever time you put. If you want it to run daily at 2 a.m., it's going to run daily at 2 a.m. If you want it to run on the 1st of January every year, it will run on the 1st of January every year. So it automates the entire process based on a given based on a specific time. Then we talk of workflow orchestration. Now, what this means is that Airflow is like a central tool that is used to manage all data pipelines. It is used to manage the entire process and ensure that everything is running in its correct order. So Airflow is like can I liken it to a football coach right now? Similar to that, it could be seen as a football coach that organizes the players on the field. The coach does not go to the field to play the football match, to play the match, but rather organizes the players. So Airflow is like the coach. The Airflow organizes all tasks, everything, and ensures that everything runs smoothly. So when it comes to orchestration, the purpose and the aim of Airflow is to organize the whole task and ensure that everything is running in its correct order. Then we talk of managing dependencies. Now, another thing with Airflow is the way how it even organizes workflow is through dependencies. Because when writing your programs in when writing your DAGs, you're going to specify depending on what the number of the processes that you want your pipeline to go through. Depending on the processes that you want your program to go through, you're now going to specify if a certain part of your program finish will finish executing before another part starts. That is what dependency is all about. Does say task 1 depends on task 2. Now what that means is, will task 1 run after task 2 complete or not? So Airflow has a way of managing all of these dependencies such that everything works smoothly and everything runs and everything runs well, so that if a task does not finish and another task is dependent on that task, the second task would not start running until the first task completes before the second one starts running. So Airflow helps us manage dependencies like that. So we can say, since we're always talking ETL or ELT, if you're writing a pipeline, extract, transform, and load, we already know the steps that it has to be extracted. Then it is an ETL. Of course, the next will be transform and then finally load. But if you're running an ELT, we know that the steps will be first to extract, second to load, and third to transform. So when you write your DAG, you write it in such a way that the system understands that it is going to perform the extract function first. And if extract does not complete, the transform function does not take off. If transform does not complete, the load function does not take off. So that is another thing that Airflow does, and it does it very, very well, which is one of the reasons why we as data engineers, we need to put Airflow in as one of the serious solid tech tasks that we have. Then also in monitoring workflows, this one can be used in monitoring ETL and ELT workflows. The web interface is a very, very good way of monitoring these tasks. So we can use the web interface to monitor our pipelines so as to see the successes and those that have failed, and also to debug, because the Airflow gives us, also provides for us a log, and this log saves every time an Airflow runs. If it succeeds, you're going to see it in the log of that particular task. So the user interface helps us to monitor our workflows to know where they fail and they succeed. Then we're looking at next, please. Okay, so we're looking at understanding DAGs. Now, what is a DAG? Anytime we're talking Airflow, we're always talking about DAGs, because DAGs is a group of components, also called tasks, that make up a workflow. Now, DAG is a combination of everything that makes up the automation process in our workflow. That is what a DAG is. And it simply, let's also note that it is saved in the DAG folder. If you write your DAG and you save it in any other folder, it will not be seen by Airflow, because the DAG folder is the only place that Airflow goes to search for DAG. So when you write your DAG, ensure that you save it in your DAG folder. Then for DAG, the G stands for directed, and directed simply means an ordered flow of tasks and their dependencies. Now, what this means is the direction is ordered. The direction is ordered. It might have branches, but the direction of flow of tasks, the direction of the workflow is always ordered. Then we talk of A, which is acyclic. This simply means there are no loops. Acyclic means there is no cycle. So there is no loop in when you're when you're automating tasks using Airflow. Now, each task runs only once per DAG run. Now, what this means is that if you look at the image underneath it, you see that there are 5 tasks there. We have task 1, task 2, 3, and 4. Now, task 1 runs first, next task 2, then after task 2, 3 and 4 runs, and then finally task 5 runs. And we're looking right now at the black arrows, and that is simply the flow of operation, or the flow of execution of tasks in DAG. The red line that goes from task 4 to task 2 is not accepted. It's not even done in Airflow. Now, if a line goes back from task 2, from task 4 to task 2, that means once task 2 completes, it executes task 4. And when task 4 completes the execution, it goes back to task 2, meaning that task 2 is going to will run more than once when this DAG is being run. Such a situation is not done in Airflow. Each of these tasks, they run only once whenever we are running a DAG. Each of the tasks run just once, and at the end of that, in the next scheduled run, it starts all over again and runs each task just once per DAG run. So that's what acyclic means there. Then graph is simply the entire components of a DAG and the relationship between them. All right, the image above showing the various tasks can also be called a graph, because looking at it, it shows the relationship between the different tasks and the different tasks that are in our DAG. So that image there is known as a graph. Then so we're looking at the architecture of DAG. Now, this is simply how DAGs are being written. So first of all, we start with the DAG keyword. First off, we start with the DAG it's a method. Yeah, we start with the DAG method, and it has some parameters, though not all of them is written there. So we have the start date. Now, the first parameter there, the start date, tells the date that the DAG will start running. Now, let's also note that the start date is usually written in the past. You can take it one day behind, but not the present or the future. So let's also take note of that. Then schedule is simply how often the DAG will run. That's what the schedule does. Then we have the catch up. We have default arguments that houses different arguments. Then we have retries. These are different parameters that are accepted in the DAG object. Then after that, after declaring your DAG, defining your DAG with each parameter, the next thing we put is the task that we want to perform. Now, these tasks are written as operators, mainly as operators or as sensors. Now, what is an operator? And what is an operator? An operator is an inbuilt. An operator is an inbuilt task that tells that tells the DAG the specific task it will execute. Now we have like the bash operator. The bash operator tells us that the task that will be operated in that line is a bash script. Then we have the Python operator. The Python operator tells us that what we are going to execute in that code, in that block, is a Python script. Then we also have the email operator that helps us to send out emails or send out notifications. Then we have sensors. Now the sensor is also a kind of an operator, but the difference between the sensor and an operator is that a sensor waits for an external event to occur. The sensor waits for something to happen before all other things run. Now, for example, we have the file sensor. File sensor can be used if we are trying to check the availability of a certain file before, let's say, before we save into a file. Let's say, for example, we want to save into a daily sales file, and the sales file, we will only save into that file if the sales file has been ingested into our system. So we can use the file sensor to keep tracking and to keep trying to know when the sales file has been loaded into, it could be in our database. So we could use the file sensor to keep tracking to know when the sales file has been loaded into our system, and after that, it executes any other command that we want it to execute. Also, we have the HTTP sensor. This enables us to, this is used for APIs. This is used for APIs if we want to keep checking to see if there are new files in a certain, in any API we're using or in a website. Now we use the HTTP sensor. So sensors are basically used if we need to, first of all, check or check for an event, an external event outside that of our DAGs. And if that event occurs, it triggers the sensors are triggered, and every other thing that needs to be run will be executed after that. Then we will now talk of task dependencies. Now, this is just a way of telling Airflow that out of these 5 tasks, task 1 is dependent on task 2, task 3 is dependent on task 1, and all of that. Now, when we use a double greater than sign, it simply means an upstream dependency. Now, what that means is, like the example we have there, that task 1 double greater than task 2. It means that task 1 is an upstream of task 2. Now, what it means again is that task 1 has to finish executing first before task 2 starts executing. Now, that is what an upstream means. Then when we use the sign double less than, that is a downstream dependency. Now, like the example given, task 4 downstream of task 3. Now, what this means is that task 3 has to execute finish before has to finish executing before task 4 starts. So task 4 is dependent on task 3. So in other words, we can say task 3 is an upstream of task 4, while task 4 is the downstream of task 3. So double greater than tells us the upstream dependency, while the double less than gives the downstream dependency. Then we also have a multitask dependency, and this is written in double in brackets, regular open and close brackets. Now, given the example there, we have that task 2 is an upstream of task 3 and task 4. Now, what this means is that task 3 and 4 are dependent on task 2. So task 2 must finish completing before task 2 must finish executing before task 3 and task 4 start executing. We can also break this down in 2 lines. We can remove the brackets, and in 2 lines we say task 2 greater than task 2 is an upstream of task 3, and also in the second line we say task 2 is an upstream of task 4. But using a multitask dependency, chain dependency, that's a bracket, it simply tells us that task 2 has to execute first before task 3 and task 4 is start executing. So okay, this is now an example. Now in this example we have 5 tasks, and the task dependency is as written below. First off, task 1 is an upstream of task 2. So that's the double greater than sign. Then next we have that task 2 is an upstream of task 3. Then in the second line we also have that task 2 is an upstream of task 4, because looking at the image we can see that the arrow from task 2 points to task 3 and task 4. So that shows that 3 and 4 are dependent on task 2. Then finally we have that task 3 is dependent on task 5, and that's why in the first line after task 3 we have the upstream image, which is the double greater than sign to task 5. So the task written on the underneath with the upstream dependencies is the how dependencies is written for a graph like this, as shown in the image there. So next I'll just like you to try this. Okay, so next is just a an exercise. We have a graph there, and I would like someone to try and just give us the reasons why. We have A, B, and C there. Which do you think is the task dependency for the graph written above? Is it A, is it B, or is it option C? Anyone?
I'll say B.
Okay, so why do you say B?
Uh, Hold on, please. Let me just check properly again and comment. Uh,
Oh,
Okay,
yeah.
I'll say C.
Sorry?
C. Can you hear me?
Yes, I can.
I think. Okay, I said the line is breaking.
Wow. I hope that has not been the case. Can you hear?
Okay, I think I can. Let me just. Hello, what did you say?
So you said the hold on. So you said is C. So why?
Okay, from the. I hope I'm getting this thing right. So I said from the diagram, I believe
Okay.
tax one is the downstream of tax one, two, three. Tax one is the downstream of tax two, three, and four. So tax one will have to run, then before we have tax two, and then tax three, and then tax four. Then for tax five is has to run only when tax three and four. So tax five is the upstream of both three and four. And I think that's what that C is saying. Yes, and there's no dependency between tax 2 and 3 and 4. Dependency only exists between 3, 4, and 1. Yes, I hope I'm also saying what makes sense.
Okay. Thank you. That's fine. Thanks for your response. I think I saw after raise his hand. Do you have a contrary opinion? Or does any other person have a contrary opinion?
Good evening, Ogochukwu. Good evening, everyone. So just to add to what Steve said, from this diagram, we know tax one is the first tax that must run. So I think that would eliminate tax. That should eliminate option C. So we are going downstream, which is tax two. After tax one, we go to tax two. Then we go to tax three, tax four. So just like Lawrence said, we will have to tax one must run first, then followed by tax two. Then for tax five to run, tax three and tax four must go first as well. So I think it will be a B. That's what I'm going to just add. Yeah. Thank you, Ogochukwu.
All right. Thank you very much for that. Then, thank you for your response and for your contribution. Do we have any other person that is answering or something? Okay. So the answer is actually C. So let's look at it one after the other. If we're looking at option A is like a single straight line that's going from task 1, 2, 3, 4, and 5. It's just a straight line. Each task is dependent on the others. Now, then we talk of B. Now, if you look at B, first of all, task 1 will execute, then followed by task 2. Now, after task 2 executes, task 3 and 4 execute. Now, after task 3 and 4, that we have 5 executing. Now, the problem is that's actually not what the diagram wants, what the diagram says. because task 3 and 4 is not dependent on task 2. So if B is option, it means task 3 and 4, they are dependent on task 2, not on task 1 alone. So then when we look at the third option, we see first of all that task 2 is a downstream of task 1. Being a downstream of task 1 means task 1 is an upstream of task 2. So now what this means is task 1 will execute first before task 2. Then we also have that task 1 is an upstream of task 3 and task 4. So if we look at it, we can see that task 1 is written as a downstream of task 2 and an upstream of task 3 and 4. So, task 2 is written as a downstream of task 1, and task 1 is the upstream of task 3 and 4. No, is this nice? Hello? Marvellous, I can't see your screen any longer.
I can still see it, Ogochukwu.
Oh,
it has gone now. It has gone now.
Uh-huh. Okay, so I was just trying to point out, but from that diagram, from the graph there, C is actually the correct answer, because it shows the dependency as is written, as is shown on the graph. Then, is that still here? He has left. Let me see if I can. Oh, my PC will not. Okay. If someone else is logged on with his or her PC, please help us. So let me try if I can join with mine. Just a minute. Because I want us to run some DAGs today. What am I doing now? Oh, okay. Thank you, Marvellous. Thank you, and welcome back. Thank you, and welcome back. I think.
Yes.
No, it's fine. Thank you. So, C is the task dependency for the graph, and that's it. So let's go to the next one. Next slide, please. Fine. Okay, then next is Airflow scheduling. How are these things? How does the schedule happen? Now, one of the parameters under the DAG is the schedule, and the schedule accepts three different means of scheduling a DAG. First, it accepts either a clone expression, or it accepts clone preset, or date time delta object. Now, first off, what a clone expression is a series of 5 asterisk characters separated by a space that indicates, using clone expressions, we can determine when the DAG is run. How do I explain it now? Okay, it's a series of 5 asterisk characters. Now, each of these characters stands for either, okay, the first one starts for minutes. That's the first asterisk character stands for minutes. The second character stands for hour. The third character stands for day. The fourth stands for month. and the 6 stands for weekday. Now, all of these, these characters accept different numbers, like the one for hour accepts between 0 to 12. Then the one for minutes accepts between 0 to 59 and all that. So now you have to calculate if you want it to run at a certain time. You can use cone expressions. If you want to schedule the DAG to run, say on a daily basis, you can use cone expression, get the cone expression for daily at a particular time, and it gets run at that particular time. Now we have 3 examples there. The first one is, the first asterisk is written as a 0, then the remaining as 4 asterisk characters. Now, what that means is it runs every hour. That cone expression stands for hourly running of the DAG. Then the next one, 15 and 15 asterisk, that means that it runs every 15 minutes. Now, that cone expression stands for the DAG running for every 15 minutes. Then we have the next 0, 8, and 3 asterisk. Now, 0, first of all, the first 0 there is the hour, is the minute part, and 8 is the hour part. So what that does is at 8:00, which is 8 a.m., 8 a.m. daily, if you set your DAG like that, if you schedule your DAG like that at 8 a.m. daily, that DAG runs. Then we're talking of cone presets. These are just easier ways of writing a schedule, and you can simply use either at hourly, daily, at once, at weekly. These are cone presets. Of course, all of them written in string characters. Then we also have the time delta object. You simply add as the schedule. Now, time delta also accepts certain parameters. It accepts days, minutes, hours, seconds. I think it accepts milliseconds. Yeah, I think it accepts milliseconds also. So you know the time you want your DAG to run. You set it, give it the correct time, and using the time delta, and you schedule your DAG with the correct time you need it to run, and it accepts that. Then then we're talking of DAG structure. Now, for a DAG structure, first off, we start with DAG. DAG, there is DAG keyword. Then in brackets are all of the parameters that we need to include in our DAG. So what is written here is just the basic parameters that at least we need to run every DAG. First of all is the ETL number for DAG is the name of the DAG. Then, of course, compulsorily we need a start date for the DAG. And a date time is used. Citing it for the 1st of November 2025. And our schedule means it is to run daily. Now, after that, the next thing we'll now do is to now write out the various tasks that we want the DAG to run. After writing the task that you want the DAG to run, then next you now put in the task, the dependency. Now, if you do not put a dependency, the DAG, any of them can run at any time. Once the time to run the DAG comes, once the schedule time comes, it can choose to run task 2 instead of task 1 first. So if you do not declare your dependency, the DAG can run as it pleases. So the third is just the dependency, which tells us that task 3 executes first, next task 1, and then finally task 2. And then lastly, we now have an example of a workflow. So we have an example of a workflow. Now, what this does is, first of all, like we said, DAGs is written in Python, and we know how to import things in Python. So for you to use a DAG, you need to import it from Airflow. So Airflow is the package, and we have to import DAG. Then next we import the datetime, because we use datetime as our start date. We use the datetime keyword to show to specify our start date. So we need to import that. Then finally we use the Python operator. So we need to also import that operator. Also, let's also note that any operator you use, like here we use just the Python operator, and we have to import it from airflow.operators.python. Now, if you're using the bash operator, you will have to import it also from airflow.operators.bash. Any operator you're using, same with sensors. Anything you're using, you have to import each of them. Anything you're using in your task, you have to import each of them separately. Then, after importing the various packages that we need, next you now define functions. So in this example, we defined just two functions that will print two things. The first one prints, this is a print statement, and the second is, this is a second print statement. So after importing, next is the main body that you want to execute. If it's your ETL, after importing everything, you write your complete ETL code. You write it like you usually write your functions, and call all of them. So you write your functions. Then after that, you now declare your DAG. You now call your DAG. Now we're using def argument. That's another parameter that is in the DAG. That's another DAG parameter. So here we just define certain arguments. We have the owner. For owner, you put any name, and then we define the start date, date time and of 2025 11/1. Then finally, we now start our DAG. Now using the with keyword, with DAG, we have the DAG name. We call the default as, oh, that's not correct. That should be ARGS. That should be ARGS, not ADRS. So the default arg will be equal to the first one, the one that that arg that we declared as a dictionary above. Then we have our schedule. So here we put our schedule that it will run daily. And after that, we write the first task. Now, the first task is a Python operator, and that task is the first function that we defined, which is print text. So how we do, first of all, is after writing the kind of operator, next is the task ID. We write the task ID in quotes, and then use the Python callable to call the name of the function, that will be executed by that Python operator. So our Python callable here is print text, which is the name of our function. That's for the task 1. Then for the task 2 is the same thing. The only difference is your Python callable it calls the name of the function which you have written, which you have defined already before writing the DAG. So in our second task, our task 2, of course, task ID is print2 to make them different. Then the Python callable there is print again, print underscore again, which is the name of our second function. And then finally, we did the dependency to show that task 1 is going to execute first before task 2. So I want to. So this is just a simple workflow for that, and I'm trying to connect here. So run some DAGs from my system. Oh, gosh. So please, you guys should be patient with me a bit, and let me see if I can join from my PC here, because let me join in, so I'll see how to share my screen from here. So why I am trying to work with this, if anyone has any questions, please let me, even though I can't. But if you have any questions, please you can ask. For now, why I try to join in when I speak. Sorry, hold on, please. Give me 2 minutes. Hold on. Okay, sorry. Quadri, please. Oh, sorry, please. Okay, sorry about that. Quadri, you can ask your question, please.
Yeah, good evening once again. Good evening, everyone. And thank you for this wonderful lecture. Yeah, I want to ask regarding what I have practiced and like in Microsoft Fabric environment, um, it has something like Apache Airflow, this data pipeline where one can, for example, now if I write Python script now in Notebook or Microsoft Fabric, and I've performed the ETL, I've extracted, I've transferred, and I've loaded the data into data lake, which is the data warehouse. Now I want to schedule the batch run so that I don't need to be running it manually. So it has something like data pipeline. So when I wrote the Python for optimize, which is incremental import, for example, I have let's say 300,000 records of tickets in the table, and I've loaded the table in the data warehouse lakehouse. I don't want to the subsequent run. I don't want to import all the records 300 and something again. I just want to import only the modified and the new ticket so that it will make the imports faster. So when I call that script from data pipeline, normally if I run the optimized one, it takes like 10 seconds to fetch the new data and the modify. But when I run it in data pipeline, I discover it's taking like 13 minutes to run. So I was now wondering, why is that? Why is it taking time in that environment? Why is it taking time to? Why is it not as fast as the one I ran manually through my notebook?
Okay. So, oh, let me understand. Because you ran in your notebook and it was faster than when you decided to run using a schedule on Fabric environment. Am I still here? Can you hear me?
Yes, I can hear you.
I asked
Yes,
a question.
I said the one I ran through that notebook, the Python PySpark Python notebook. It's faster because I've optimized the script. But when I call that script in environment like Apache Airflow, where a data pipeline, where it will run automatically by itself at a specific time. So when I try to test it by running it, I discover it takes time and it's still the same speed. The pipeline that will run it automatically takes time to complete, unlike the one I ran through that Python notebook. But it takes like almost 30 minutes to finish. But the one I ran through notebook, that optimized script or incremental data ETL, it took only like 10 seconds to complete.
Okay, so maybe you have to look at how you, if there are other parameters that you can add. Now, how the dependencies, you did them well, right? Because why I'm asking is that at times, if A does not complete running, or maybe there is an issue running one of the tasks, it will usually take time. And if it doesn't complete, it will definitely delay that of other. So you have to look at your script well to ensure that if you're writing, to ensure that if it is running, that everything runs well. And I would also suggest, first off, I would suggest that you look at the time. Using Fabric, you can monitor the task, right?
Yes, exactly. I can monitor it. I can check the time it takes to run. Yes. I can check the log.
Log. Exactly. Use the log first of all and see if there is any that is actually causing that delay. If it is when it's loading the first time, or when it's when it's adding to an already existing file. Check for the one that is causing the delay and see how you can work around it. Because situations
All right.
like that, if the delay persists, that's for the downstream task, yeah. If it persists, the others will definitely delay because they are waiting for one to be ready before they start executing that. So just check first off. So just check if there is anyone causing that delay. If there isn't, then if there is, you can check through the logs to know how long they are all executing.
All right. Thank you.
All right. I'm trying to join here. Let me see. I hope this doesn't. Hold on, please. I'm trying to see how to join in my PC so I don't get to discuss this thing. Oh, Steve, Steve, let's hear you.
Okay. Good evening. I hope you can hear me.
Yes, I can.
Okay. So I was working on some projects, like I think two. I don't know if I said the first one already, but I think the first one was when I was trying to extract
Yeah.
some records from a particular site that will not let you get records except you actually open that file on your browser. I think I said that about the project last week. I think I talked about it the last time we had our breakout session. But I applied is it logins now to that particular project? I don't know if I can find it. So logins, is it it will just because when you run the project, it starts giving you output depending on the kind of uh, information you want. It will tell you that okay, this particular the website is opening up, the extraction has started, it has saved the particular file, it's now extracting cleaning the file and all of that. Those login details, are they saved in a specific folder in in the project repo or something, or in the project folder? That's one question. So I can find it because I don't know, I'm trying to work my way around using that login. And then another question, are you on LinkedIn? That's the two questions I have for now.
Okay. So, you can hear me, right?
Yes, I can hear.
Okay. Right now, I'm triple taxing. I want to run some DAGs for my PC, and this thing is just okay. I think since I've joined, I hope it goes well because don't disappoint me. Okay, so let me just answer quickly. Okay, so now login. When we did it last week, the first parameter was actually a log name, the file name. So what it does is in that folder, it creates immediately you run it, it creates a log file with that name in the folder you're running it. So once you run, just check. If you use VS Code, you'll easily see it. You'll see it immediately it is created. So once you run it, just check and you'll see the folder there and you can easily open it and view the log.
Oh, okay. I'll check. I know I only see it in the output, but I don't know that particular project has got any folder. It's even confusing me now.
Sorry?
I said I will check because that particular project has so many folders because I had to create like a virtual environment for it and then Git initiate Git on it. So they have so many places on it, but I will check. Probably I didn't see the actual folder itself. That's why.
Okay, so just check and it usually maybe you could just do a search on your if you're working on your PC, just search for where it is. So it's usually on the folder you're working on.
Okay. And are you on LinkedIn? Yeah, that
Yeah,
was my last question. Okay, you should have sent it to us so that we'll connect now.
Okay. Let me see. Okay. Okay, don't worry. Maybe later after the class.
Okay.
Attendance link. Right? You hold on, oh, please. I need to do something first of all before attendance link. My head right now is okay. I'm going to share my entire screen. I hope I have this running right now. Okay, so I'm clear enough, right?
Yes, you can see your screen.
Okay. So first off, use hold on, please. Let me remove this. Uh, okay, I believe we can work with this now.
Okay, I think I found it. I found it.
Okay, you send. That's where did you say?
He saved it in a folder called logs.
Okay.
So it has all of them. Yeah.
Okay. You can open and do it later. So we're just going to run some DAGs. First of all, let me even open the environment. Now, this environment. Oh gosh. Give me at least my PCL. Okay, so now this is the Airflow environment. This is the Airflow UI, sorry. Now, first off, I'm trying to open the DAGs here. The DAG here. I did one because I need to definitely waste our time during this class. So God. So I have just one DAG running here right now. Okay, let's see. So I'm just going to let's just create one. Let's call it. As mentioned before, it's always a Python file. So we're test.py.
There's already a DAG running on your system already now. From here, I can see it from
I
PSP.
know, yes, there's one there. That's why I wanted to open the UI. Is just okay. It has come up. All right. So I hope this was even written before we started, and I just tested it. So what this this is not question. Okay, let me just copy this. Let's write another one. I didn't start now with that. Okay. Yeah, this is why I don't have sense for this during our classes. Okay, so this is the example that we looked at in the PowerPoint file. And hello, am I still connected, sir?
Yeah, you were, was it, or should I call this muted before? We couldn't hear you before. I can't see your screen.
Huh. I can't- Let me try again. Okay. Okay. Uh, let me try and join back again. Oh gosh. Where is it? Yeah. So I'm having challenges here now. I can't even. Oh god. Okay, so sorry about that. Okay, so first off, where I have just one DAG running there, I want to add another one so that I'll simply edit all of this and I don't get to waste time. I'll put this here. Mine. Okay, so first of all, from here, the first part, this is where Again. Okay. This connection doing this thing. So I am sorry. This is what I usually say sometimes. But, okay, so back to the example that we gave before. Now, first off, I imported the needed libraries, that's DAG, date sign, and then Python operator. And Python operator. Let me save this first, so it will get the DAG. Let me change this name to test. Change it to test DAG, so we can see test DAG. That's fine. So let's see if my test error. Okay. So I've saved this. Then I'll just change this because they are not the same characters. Okay, so I believe everything is in order like this. Now, first off, I imported let me see, the needed library, then defined the two functions, used the DAG, and called these two functions. So then I did the task dependency. Task 1 runs before task 2. Then I'll just head over to the DAGs here. Oh, this is very happy. Oh. So I'm going to refresh and let's see if the test DAG, and let's see if test DAG is common. Usually takes some minutes. Let's see if we see the test DAG here inside our DAG. This one is going to test my network. Okay. So let's hold on and see. I need to get my name. Let's see what the error is. So we have one DAG already running here. And the second is the one we just finished typing right now, and it's giving an upload error. So this means there is something wrong with the code. So we can look through there and check to see if it's something we can, to see what the error is, so as to help us debug it immediately. All that this is happening here. Let me look through the code and see if there is anything that we are not supposed to write. This is a thing. Okay. I'm guessing these are the programs. It's just a while back. I'm thinking this is the problem, the format that was used there. So let me save and then, okay, is it coming up now? Okay, let's see. So test.py, what's the problem? Let us see. Just as I suspected. So since I typed it manually, since I typed it using PowerPoint, the double quote is not the same. I think it's not the same ASCII character or something. I'm not recognized by the same ASCII character. So that's why it's giving an error. Now we've changed this by retyping in VS Code. Let's see if it is coming. We're still having a problem. Let's see. Is it the same issue? Task 2. Inconsistent use of tab space and indentation. Okay. This one is likely because we copied. So we're just going to do all of this. This task 2. So it uses the correct indentation. I hope this is not okay. 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 And then we'll go back and refresh. Let's see. Okay, So now it has accepted it because there are no errors. So this is the test DAG that we just did. And to run it, for it to run, we simply click here. Here is to put it on. Okay, so it's on now. And let me see, how many minutes did you even give it? Oh, daily. No. Okay, we'll have to edit that, but let's see first of all. We'll edit that so it's run in say 5 minutes. Where is here? So I want to edit this because I want it to run in this class. So we're going to edit it to run in 5 minutes. That would be 6/5. 0/5. 1, 2, 3, 4. So move the ball. Okay, so why this is happening, let me open the one that I wrote initially. We'll look at the code and we'll just check the times that it did run and how it has been running for a while now. Okay, so let's see this. Why the other one is now. Let's see. Okay. All right. So this is a code that I wrote initially, and this one is to just to find PLC. That's to extract, to load, and then to transform. Now, first off, in the extract part, let me go down. Okay. So this is the extract part. This is the extract and load. Now in my folder, there is a file called sales CSV. So now, after extracting this, it loaded it directly into a sales total sales database. Now, mind you, I didn't create the database. It was just the CSV file that was stored. And from the CSV file, it loaded it straight into the SQLite database. And after that, I have to call on transform. Now, another thing we should note is why this is so is because the tasks when working with DAGs, tasks do not interact with each other. Unlike when you're running a Python script or in Jupyter Notebook, when you're calling different functions, you can call another function in another function and all of that. But in DAGs, they don't work that way. They are all treated as separate units. So after reading the file, after extracting it, I have to save it somewhere. So I saved this file straight in the database so that the next function, which is the next task, that is the transform task, will just go to the database where it's stored and pick the file, do the transformation, and then load it also. So that's why after defining here, it was loaded here straight. It was loaded into the database. Then the transformation function, of course, connecting to the same total sales database, first off to read the file and then do a transformation. Now the only transformation I did was to add another column, which is unit. Another column which I called unit column, which was to divide the total sales by total quantity, because in the original file, let me open that. Yes, yes. Okay, yeah. So this is the original sales CSV file. The first row, of course, is the column name, and here we have total quantity and total sales, but nothing like unit sales, and nothing like unit. We have just total quantity and total sales as highlighted. So in the transformation here, in the transformation, I just decided to get a unit figure. So I divided total sales by total quantity, and then added it to the database. And then finally, I called the DAG. And this DAG is meant to run every 15 minutes. Now, first off, the Python operator, getting the task ID, then the Python callable here is the extract, which is the extract function. Now, which is the extract function. And secondly, the second Python task was the transform function, which is to add the unit column to our database. And then finally, using the dependency, of course, extract comes first before loading. So that's the dependency that was written here. And these are the series of runs that it has had since we started. Okay, now this one is going to delay. Hold on, let me see. So okay. All right. So as it is now, the DAG is running. It's supposed to have finished. I don't know why it's delaying. But looking at the greens here, this greens here shows the success. Now, if we're going to look at the first time this DAG ran was, let's see. Okay, that was 6:05. That was 5 minutes past 6. That was when this first one ran. And the next one, ran at 15 minutes past 6. So now we have a DAG failure. Upstream failed. Task 1 failed. Okay. So now this DAG is supposed to run. Before we get there, there's something I want to say, guys. So let's look at, first of all, the task 1, and let's see the event log. Okay, so this gives series of errors and warning, but it did run at the end. Extraction and load complete. Let me go back to the code, so I'll get the output. Okay, so let's see. For our def function, that is the first task. At the end of the first task, we have a print statement, which is this: extraction and load complete. Then at the end of the second task, we have another print statement, which is final load done. Now these are the logs. Okay, so the last successful one, which is this, that took time about 6 minutes. Now this is how it did run for the first task. At the end, we should see, where did it return that message? Okay, so in line 17 here, we can see extraction and load complete in line 17. That is the print statement at the end of the first extract task. Then at the end of the second one, where is it? Then at the end of the second one, we have final load done. Now I added this in so that we will see the messages itself at the end of each one. So each of these greens here indicates that they were all successful. While this red showed that the last DAG run was not successful. And if we look at this, in our code, we know that task 1 is an upstream of task 2. Now, since task 1 failed, task 2 did not even run, giving us an error of upstream failed. So I want to, the course would likely be my network, because I know it has been running since. So the course would likely be my network. Let's see. So let's see the other one. Why that one is loading? Okay. So this test that we did, it's even running. So the second one that we wrote, the one that we wrote with the print statement, I think as soon as I just put it on and changed it to 5 minutes, to run every 5 minutes, it has run 4 times right now. It has run 4 times right now, and this shows success. So the first time it ran was, let's see the time. Okay, 1941. Okay, and the 1945. Okay, so the next DAG run should be, let's see, the next one will be in 1955. So once it is 5 minutes to 8, that's 1955, the next DAG would run automatically, and it will add either a success or a failure here. So the bar here will show either green or red. Blue shows that it is processing. Green shows that the run was successful, and red, like we saw in the other one, shows that there was that the run failed. So okay, see, I know this has to be my method. Now while we were here, I just triggered it manually to know if it is run, and it did run. And it did run successfully. So I clicked on this trigger. This trigger here is to manually run your DAG. A trigger here is to manually run it, and which I did after the first failure, and it ran successfully. So at 1952, it did run. Of course, the first one would run like this, and then the task 2 give us the log. And then task 2 also did run. So the next DAG run here should be at 8 o'clock. So the next one will run by 8 o'clock, and I guess we'll be done with our class then. So this is this one. Okay. This is done in the next 1 minute. That's at 7:55. In the next 1 minute, it should run. So that we have 4 successes so far. So in the next 1 minute, we should have like one more to show you that the process has been automated, and anything that we want it to do, it is going to do it for us. So that's how we run our DAG. Also, something that I want us to note here is so after running this, now after running the ETL, this is the code that I used to type it. And let's note again, to run your DAG, in the code section, you cannot edit your code there. You have to go back to where you wrote the code. You have to go back to your code editor to so you cannot edit your code here. You have to go back to your code editor to run it. To edit it, sorry. So I think that's it. Let's see. Okay, the last one. Let's see if it did run successfully. Okay. All right. So now we have five green bars here to show that this last run was successful, and that was at 7:55. This is a print statement. The other one. The second print statement. So that is how we run our DAG. Okay, let me. No. So I think we can do that one on our own. If you can try writing like 3 or 4 different functions, and then you do not add any dependency, and schedule it and see how it runs. When you check the first one, you see which okay. So when you check your logs here, you click here, you check and you see how it ran. Like in this one, because you have a dependency, print 1 will always run before print 2. And so will it continue, will it be in all DAG runs. If you click on all of these bars, print 1 and print 2 will always be the same thing. Print 1 and 2 will always be the same thing. So at your own free time, you could write up to 3 or 4 and see how it did run, and take note of the functions that run first, the tasks that actually run first before the others, without using dependencies, so that you get to understand the importance of dependency when using Airflow to schedule your pipeline. So I don't think there's any other thing. That's all right. So I think that should be that is it for DAGs for today. Let me, Marvellous, sorry, please hold on. Let me look for this attendance. So I've almost accepted my time. You can ask your question, Marvellous. I see your hand raised. Please do ask your question. Let me sort this thing out here.
All right, thank you so much. Well, I'll start by saying that maybe because it's for starters, like I'm just a starter, this is a lot to take in. So I would like to say that maybe maybe next class we can still dwell more on on the application of Airflow. So my first question is about the interface of Airflow, out to the web interface, how you were able to transition into the web interface from the coding environment, how you were able to transition to the web interface. Is it automatic, or do one have to create an account to be able to access the web interface? So that was my first question. And also I want to ask about the folder creation of tag. You said at the exception of that,
I didn't get
hello, can you hear me?
Yes, sir. You said you wanted to ask about the what?
Did you get the first question?
Yes. How to get the web interface?
Yes. So I was about asking the second question. So
okay,
the second question is that about the folder creation. You said for us to monitor the DAG orchestration, we have to create a folder for DAG instead of just having the Python folder, the Python files that host the documents or the codes. We have to create a DAG folder that will hold the Python files. So I didn't really get that concept quite well, because maybe because I'm used to the data lab for my practices. So using the VS Code, I want it to maybe be clear on the meaning of that. How do we create dark folder and those sorts? So those are my two questions. Thank you.
Okay, so I'm searching. Hold on, please. I'm searching for the attendance link. So please, you guys should be patient with me a bit. Then first off, you ask of the web UI. Let me see. Whether I should just hurriedly share my screen. I'll log out. Then I'll show you how to get to the web UI. But let me send the attendance from here first of all before I exit. Okay, so I just sent the attendance link. Please just do it to. Please, you can write the attendance now. Okay, so let me share my screen. So you'll get the answer to the first one. Okay, so first of all, I have to break this. System doesn't. Let me stop running this. I want to log out now. Anyway, the truth is, data camp has certain limitations, and I haven't tried it, but I am sure you can run. But I haven't tried it, but I doubt if you be able to run write DAGs on data camp platform because the requirements are actually heavy. So the requirements are heavy. In fact, that's the truth. Someone doesn't want to shut down again. Shut down, please. That's interesting. Close everything. So the requirements are quite heavy. So I don't think you can do that on data camp. Okay, log out. Okay. So I have everything, of course, installed. Now, I'm going to answer the second question first of all. Talking of your DAGs folder, when you install Airflow, it comes with there is Airflow Home, and there you get your DAGs folder, you get your plugins, and you get your logs. There are 3 folders in the Airflow Home folder. Now, what you don't what just do, like here I have my Airflow Home, and let me close that. Okay, so these are, we have the DAGs, logs, and plugins. It is inside these DAGs here that you get to save and you store all of your DAGs. How is this thing not clear? Okay. So we have, okay, so for you to enter the user interface, I've logged out. Let me just open another one and close. You simply use the command airflow standalone. That's it. Where you installed your DAG, the folder where you installed your airflow, that's where you use the command airflow standalone. That's the this is I think airflow 3.1 or so. I think this 3.1 is the one I'm using, if I'm not mistaken. So this is just the simple command. In lower versions, you use the I think the GB init. No, that's initialized. Airflow web server something. But with the version I'm using, just a simple Airflow standalone, and your Airflow is up and running already. So this command alone gives you access to the web interface. Oh, I'm sorry, this thing is falling, so that's why you can't. It should be moving at this point. So that's just the now when it starts running.
I carry on. S1.
Now, when it starts running, something should be here right now to show that Airflow is already up and running. Now, it does start.
Omi wa ní problem ni.
Now, when Airflow starts, you just go to your web browser and type localhost 80. Localhost 80. This won't get anything, of course. It's not yet running here, so it's not yet running. Okay. Airflow standalone. Correct me. Okay, so let me see what I typed initially. So that Airflow standalone. Okay. So now the database it is now initializing. Can you see it? It is running already. Now you can see. So the data, the server, the web GI is up and running, and I just stereo, and I'm off. Okay, so that's basically how to get the web GI. When you get to, if you're using VS Code or your command line, of course, get to the environment where you installed Airflow. Type the Airflow standalone command, then open, once it's up and running, open your internet browser, type localhost 8080, and you will see the Airflow interface. The interface will just request that you put in your username and a password. Of course, if you use standalone at the beginning, it's going to give you the password. It will automatically generate a password for you and all of that. So once you log in with the credentials, you can start making use of Airflow Home and the rest of that. So it's already coming up here. So that's how to get to the web UI. And I think I've answered the second question. I think yes. In your DAGs folder, when you're installing Airflow, you get your DAGs folder. So anything you're typing, any tag you want to type it inside your DAGs folder, and that is it. So I want to believe I answered both questions, Marvellous.
Yes, but maybe I would like if we can have a more, because I still feel like lost. But for the first question, you said creating a folder in VS Code. Maybe because I'm not familiar with the use of VS Code.
You're not creating a folder in VS Code. When after your the installation is not as easy as a simple pip install. It's not like you're installing the installation is quite complicated. So by installation that you direct you get a DAGs folder. After installation, then you work with your DAGs folder.
Okay. Thank you.
Right. See, that's why when I give assignment, I want to work outside data because this I'll say this career it is beyond data camp. Stuff is available. So your own outside data camp. I hope you get Marvellous. And also for those using those data camp, I know it will be challenging, but please we need to go beyond data camp and start working from scratch. We can usually practice all of we're talking about. I hope that's okay. Is that clear?
Thank you so much. Thank you.
All right. Thank you very much. So, does any other person have any other question? Do I have any other question? I believe no.
Just the LinkedIn.
Oh, okay. You may need to click the link again. Please. I think this happened. Okay, LinkedIn is my name, Ogochukwu, and A. That's all.
Okay.
So I think that should be all for today. Please, the person that said you can't click, that's Oyetunji. You're not able to click the link again. Okay, please send you can please a message on this. Hello? Oyetunji, please send me a message on this that I'll send you the link there. But try and do it before 8:30 because at that time the form will be closed for submissions. So I don't think we have any. If there is no other question, then I think we'll have to call it a day. Okay, so from the look of things, I don't think there's any other question. So if there isn't, I want to say thank you again for joining in today. And like I said, please, next week will be our last session. We are going to touch on Airflow, still Airflow, but we are going to do some advanced Airflow, advanced stuff in Airflow. So I just hope this thing, I don't get disappointed next week. But that's what we're going to also look at next week. Then that will be our last session. We're ending all of this in November here, so that in December we're taking other things. Then also next week, I'm also going to talk about the project. Yeah, I talked of the capstone project last week. So it will be ready next week, since that will be our last session. I'll endeavor that it's ready before next week. If I'll send it before Saturday, I'll send it to the Discord channel. So we just talk on it next week and talk of submission, and then we'll just do a final review of everything that we've been talking from the beginning of, that should be July, yeah? From July, we'll just do a brief review from July, then we're going to end next week. So since we have nothing else, thank you once again for joining, and I do hope that you all will be here again next week, and we get to say our goodbyes officially next week. So thank you for today, and enjoy the rest of your evening. Gracias. Thank you.